Good morning everyone. Myself Dr. Harjinder Singh. I am lecturer in mechanical engineering at Government Polytechnic College, Firozpur. Today I will discuss transmission system and its main components like gearbox and others. Firstly is what is transmission? As power is developed in the engine and the vehicle is driven by wheels, so there is a mechanism, there is a number of components which transfer power from engine to wheels. The whole system is known as a transmission system, which transfers the power from engine to wheels. So why we need manual transmission or transmission system? Actually, the engine is developing power in a narrow range of torque and RPM, while we need larger range of speed and torque for starting a vehicle from rest position, secondly to accelerate from low velocity to high speed, and to continue driving at high speed. So we need a larger velocity range and torque range than the velocity and torque developed by the engine. So the transmission system is designed to change the vehicle's drive wheel speed and torque in relation to the engine speed and torque. And what should be the features of transmission system? It should be able to increase the torque to the drive wheels for quick acceleration, supply different gear ratios to match load conditions. In case, for example, if we see the vehicle starting from rest position to motion, it is encountering the static friction, which is more than the dynamic friction. So when vehicle starts from zero velocity to motion, it requires larger torque, wheels require larger torque and lesser RPM. And then second condition is when vehicle is accelerating from low velocity to high velocity. Thirdly, when vehicle obtains maximum speed and the vehicle is continue running at that speed. In all three conditions, first condition when vehicle starts from rest, it requires larger torque, lesser RPM. In next case, still lesser torque, larger RPM. In the last case, when vehicle is cruising at constant speed, say 80 km per hour on the highway, it requires lesser torque and higher RPM. So in motion, we are having different torque requirements and different speed requirements. So all these requirements should be fulfilled by transmission system. In addition to this, it should also provide a reverse gear to take a vehicle in backward motion, and also it should provide easy means of shifting gears, and lastly it should operate quietly with minimum power loss. And next is a main component is gearbox, and in gearbox we are having gears. First we will learn the gear fundamentals. What are gears? Gears are round wheels with teeth machined on their perimeter on the surface. They transmit turning effort from one shaft to another. When gears are of different sizes, output speed and torque change. Now in this slide we will see that how torque is changing. See in this yellow shaft with gear, say the power is coming in this shaft, it is driving the gear having 10 tooth. It is matched with the output shaft through this gear, bigger gear which is having 30 tooth. So what will happen? Power will come in this shaft, it will drive same RPM this as that of shaft. but the speed of the output shaft will be reduced to 1/3, and torque will have torque 3 times. So when the smaller gear is meshed with the larger gear, we get higher torque but lesser RPM. See, this is the second case when larger driving gear is meshed with smaller gear. In this case, power is coming in this yellow shaft. This is input shaft coupled with this gear. Then this gear will be running at 10 RPM. It is having 3 times the tooth of power output shaft gear. So output shaft will be running at 3 times the RPM of the input gear and shaft. So from these slides we conclude that the purpose of transmission can be divided into 3 parts. First is ability to alter the shaft RPM, second is to multiply the torque, and third ability to reverse the direction of shaft rotation. Next, the term is the gear ratio, which is commonly used for designing gearboxes. Now, what is a gear ratio? The number of revolutions in a drive gear must turn before the driven gear completes one revolution. We can say this is the definition, or mathematically it is calculated by dividing the number of teeth on driven gear by the number of teeth on the drive gear. So, it is the ratio of number of teeth of driven gear and number of teeth of drive gear. Say drive gear has 12 teeth and driven gear has 24 teeth. So, the gear ratio will be 24 by 12, it will be 2, or it is written as 2:1. Now, this slide is again showing the gear ratios. This is driving gear and upper is driven gear. When these gears are in mesh, driven gear is having 24 teeth and driving gear is 12 teeth. This is the side view. When the driving gear is running anti-clockwise, the driven gear will run clockwise. This is the this diagram tells about the direction of rotation, and also it makes clear that driven gear will make half revolutions than the driving gear. Generally, gearboxes are designed in such a way that the first gear is having 3:1 ratio, second gear 2:1, third gear, which is also known as high gear, as 1:1. 1:1 means that the output shaft is having the same speed RPM as that of engine. And last is the reverse gear. When reverse gear is that gear which takes the vehicle in backward direction. So again, the reverse gear will be having a gear ratio in the form of 3:1, but that is the same as that of first gear, but the direction is reverse only. As we have learned that when a smaller gear drives a larger gear, it increases the turning force or torque, and it is used in low transmission gears, say first, second. And there is another term used in automobiles, that is overdrive ratio. It is a condition when gearbox is giving RPM larger than the engine RPM. That means the output RPM is more than the engine RPM. It is not provided in all vehicles, it is in high speed cars and some vehicles. When we are having overdrive ratio, the output gear will be increasing the speed of vehicle than the engine speed. and because the power is a combination of output, torque and speed, so the torque will be reduced. And for the construction of gearboxes, there are two commonly type of gears used. One is spur gears and other are helical gears. And conditions of spur gears are that when it runs, they produce some noise, and construction is like that. The teeth are cut parallel to the center line of the gear shaft, and spur gears are generally used for sliding gears such as reverse gear. And another category of gears is helical gears, and in this case the teeth are machined at an angle to the center line, and their running is quieter and stronger than spur gears, used for main drive gears which are in constant mesh. And this slide tells about what the gearbox does. Power, here we see this power is given by the formula 2 pi n t over 60. So, power is a combination of RPM and torque. As I have already told that the engine develops power in a narrow range of torque and RPM, whereas the gearbox helps us to get wide range of torque and RPM as required based on the different load conditions. But and second main question is that what is gearbox is doing? Is it developing power? No, it is just altering the combination of torque and RPM. It has nothing to do with the power. Here we see the two gears are in mesh. One gear is in, if one gear is revolving in clockwise direction, then other gear will move in anti-clockwise direction. For example, if we want to have same direction of rotation of output shaft, then what we will do? We will put another gear in between the idler gear in between these two gears. So, in this case, the driving gear is running into anti-clockwise direction, idler gear is running into clockwise direction, and output shaft is again running into anti-clockwise direction. So, we are getting the same direction of motion as of input shaft and output shaft. This is the principle used for putting a reverse gear. As I have discussed already, when we put larger gear with the smaller gear, if the smaller gear is input gear and output gear is larger size, we will get the reduced RPM. Say output gear is having 3 times RPM, so 3 times the number of teeth. So, the RPM will be reduced to 3 times. Say input gear is having 900 RPM, then output gear will have 300 RPM. And similar is the torque multiplication. The change of torque from input gear to output gear is directly proportional to the gear ratio. Example, if the gear ratio is 3:1, engine turns input gear at 900 RPM, say with 50 pound per feet of force, then output gear turns drive shaft at 300 RPM with 150 pound per feet of force. So, see this input gear is having 900 RPM with 50 pound per feet of force. The output gear drive shaft will be having 300 RPM with 150 pound per feet of force. So, RPM is reduced, but torque is increased. Again, this is showing the smaller gear. Driver gear is having 25 teeth as matched with driven gear having 75 teeth. Again, in this case, the gear ratio is 3:1. The output gear will be having 3 times torque, but RPM reduced to 1/3. So, this is the chart, gives the different gears placed. When we put first gear and an automobile, say engine is turning at 200 feet per pounds torque with 2000 RPM and gear ratio is 4:1, the output shaft will be having 4 times the torque, but RPM is reduced to 1/4, that is 500, and this condition is under drive. That is, we are decreasing the speed of output shaft in comparison to the engine. Similar is the condition with the second gear. In the second gear, the output torque is still reduced and RPM is increased. So, first is the condition when the vehicle takes a start from rest to motion. Second is the case when vehicle accelerate from low velocity to high velocity. Now, in this third case, when we put third gear, the gear ratio is 1:1. The output shaft will be having same RPM as that of engine and the same torque as that of the engine, and this is also known as a direct drive. And last is overdrive. See, in this case, overdrive is ratio is 0.5:1. That means the torque is reduced from the engine torque to half and RPM is double the engine speed. This gears is placed in high speed cars only. We are having different types of gear mechanisms. First is the sliding mesh type gearbox. As the name indicate, gears are slided to mesh with the driving gear. So, we call it as a sliding mesh gears. For sliding these gears, lever mechanism is used, which is not shown in this diagram. This is the just diagram shows the position of gears and how they mesh and how the power is transmitted from one shaft to another shaft. Say in this first case, this is the condition of first gear in place. This shaft is clutch shaft coming from the engine after the clutch, and this gear is known as the clutch gear. This is wheel. When the engine is running and clutch is engaged, this clutch shaft is running and a positive gear is meshed with this. So, this gear will run and this gear is mounted on this is a lay shaft, and other gears are also mounted in 3 gears are also mounted in this lay shaft. When the engine is running, clutch is engaged and gearbox is in neutral position, the lay shaft will be running all the times and all the gears will be running. But when we place first gear, that means the gear which is having large number of teeth is engaged with the smaller gears, say in this condition first. So, the power will come from this clutch shaft to this gear, it will transfer to the lay shaft gear. Lay shaft gear is moving this shaft with the same RPM all gears, and from this lower gear, the gear which is having lesser number of teeth is matched with the gear with the larger number of teeth. This will transfer power to this bigger gear, and we are having output and in terms of reduced RPM and increased torque. So, what will happen when the second gear is engaged, first this gear will be disengaged. See, in this condition, second gear is placed, this gear is slided backward from this position, and this gear is slided to mesh with large second gear. Now, in this case, the power is coming from clutch shaft to clutch gear, then lay shaft from this second gear to this gear, and from this gear to the output shaft. So, see, in this case, in comparison to first gear and second gear size is larger than the first gear size. So, first gear on the lay shaft, it is meshing with the smaller gear on the main shaft. So, this main shaft will be running in comparison to the first gear at larger RPM and will be having lesser torque. So, when the third gear is placed, all first and second gear are disengaged, and this third gear is meshed with the third gear on the lay shaft. In this case, we will be having output RPM more in comparison to the second gear and torque less. So, as we move from first gear to second to third, we are increasing the RPM of the output shaft and reducing the torque, and this is the condition of top gear or direct gear. In this case, the output shaft is coupled to the clutch shaft directly. So, we are getting the same RPM as that of engine shaft to the output shaft. So, when we want to place a reverse gear, this mechanism shows the reverse gear, in which a idler gear is there. First power comes to the smaller gear, then it goes to the idler gear, then idler to reverse gear. In this case, the direction of motion from first gear to reverse gear is opposite. What are the disadvantages of sliding mesh? Firstly, as we have used spur gears, these type of gears produce noise, and there is a difficulty of obtaining a smooth, quick change of gear without the great skill and judgment. As in this case, when we want to engage any gear, lay shaft gears are always running at different speed, and output shaft gears are at different speed. When we engage these type of gears, there are chances that they may clash because of different peripheral velocity and may damage the teeth. And there is another gearbox which is a constant mesh gearbox. In this gearbox, all the gears are in constant mesh with the corresponding gears on the lay shaft. The gears on the splined main shaft are free, and the dog clutches are provided which are free to slide on the main shaft. The gears on the lay shaft are fixed. See, in this condition, this is a pictorial diagram of constant mesh gearbox. As we have seen that in case of sliding mesh gearbox, when we engage gears, since the gears are at different speeds, there is a chances that while engaging they may damage the teeth. It is a improvement over the sliding mesh type gearbox, where we are having all the gears first or reverse gear, low gear, second gear are engaged with the lay shaft in all conditions. But see how the power will be transmitted. In this case, this is clutch gear, this is the clutch shaft coming from the engine side after clutch, and this will rotate the gear on the lay shaft. When the engine is running, clutch is engaged position, this clutch gear will be rotating in rotating path. This will revolve the this will rotate the lay shaft, and all the gears on the lay shaft will be rotating with the same RPM as that of shaft. Because these all the gears are engaged, so all the gears in the main shaft will be running at a different RPM, but the gears on the main shaft are free, they are not positively coupled. But here we are having dog clutches which are positively coupled through splines on the main shaft. When this dog clutch will revolve, will rotate, and this will rotate the output shaft. So, when we want to put any gear, what we do? We move this dog clutch to engage with the dogs on sides of the gear. As these dogs will engage, the power will come from, say, in the first gear, it will come from this lower gear to higher gear to dog clutch, and dog clutch to output shaft. And when we want to engage second gear, we will disengage this first dog clutch and engage this second dog clutch with the second gear. So, in this way the power is transmitted through dog clutches. What is the advantages? What is the advantage of having dog clutch over the sliding mesh type gearbox? In this case, the dog clutches are hold the whole periphery. When they mesh larger number of dogs in comparison to the number of gears in number of teeth meshed with output gear in case of sliding gearbox. So, again the same problem will arise here when we will engage the dogs with the side dogs of the gear. These might damage because of difference in speed. Although it will be having some advantage, as the gear remain always in mesh, it is no longer necessary to use the straight spur gear. Instead, we can use helical gears which are having quieter running. Also, the wear of dog teeth on engaging and disengaging is reduced, because here all the teeth of the dog clutches are involved compared to only 2 or 3 teeth in case of sliding gears. Next is the Synchromesh gearbox, which is quite improved as comparison to the sliding mesh and constant mesh type gearbox. Similar to the constant mesh type gearbox, because all the gears on the main shaft are in constant mesh with the corresponding gears on the lay shaft. The gears on the main shaft are free to rotate on it, and that on the lay shaft are fixed to it. This slide shows the how the synchromesh works. See, in this first case, synchromesh uses the friction between the mating conical surfaces of the two components to modify the speed of one of them. Say we are having this shaft which is having conical surface inside, another shaft which is having cone frictional conical surface. When both these shafts will be in mesh, as in the case of 2, we can increase the speed of first, the increase of speed will be transferred to the second shaft through friction of the conical surface. Now, in this case, second case, in addition to the conical surface, there are the dogs attached on the periphery of the shaft. In this case, when these two mesh, firstly the conical surface comes into contact, which increases the or equalize the speed of both shafts. After then, these dogs are meshed. After meshing, we are having a total positive output of the shaft. So, these three conditions shows the working operation of a synchromesh unit. Now, this is the actual construction of the synchromesh system. This is a gear on the output shaft attached with the dog on the sides. side periphery having the conical surface, and this is the synchromesh system. Here is a slot in which the lever is placed to move towards the gear, and when the gear is engaged, this whole of the assembly moves towards the right, towards on the cone. Say in this condition, the whole synchromesh unit has moved near the